Hello, welcome to 7.7, Solving Radical Equations. This is the last lesson of Unit 7. And thankfully we've been practicing solving with the radicals, so hopefully this won't feel as overwhelming because you've seen little bits and pieces along throughout this entire unit. So let's start out with some review. We got 2x squared equal to 48. Our goal whenever it's a single x squared, x cubed, whatever term that might look like, we want to isolate the variable. So we do want to get rid of the 2. So let's divide that here on both sides. We get x squared equals 24. Now, when we're doing this, we want to take the square root. You want to do the inverse operation. And because 24 isn't a perfect square, we're going to try to break it down. We would get 4 and 6. 4 breaks into 2 and 2. 6 would break into 2 and 3, but it's not necessary because it won't reduce anymore. So then our answer here would be 2 square root of 6, but because I took a x squared and I took the square root, even roots are going to result in plus or minus solutions because we could have the positive or the negative for this. So this would be our answer here. Next one, similar process. We still want to isolate the parentheses here because that's where the variable is attached. Don't distribute. Remember, we have a cube that is affecting the entirety of the parentheses. That takes priority over the 3. So instead, let's subtract 4. We would get 81, 3x minus 2 cubed. And because we're not giving you a calculator to work through these, it should be something that you're more familiar with, something we've seen a lot, and we've definitely come across this situation where we break down 81 by a factor of 3, and that ends up being 27. Unfortunately for us, 27 is a perfect cube because to undo the cubed power, we got to take the cubed root. So these parts are inverses, so we're left with x minus 2 equal to 3. Then we would just add 2 to both sides. We get x equals 5 for our final answer on this one. And if you wanted, you can always take your answer, check it in the solution. So if I did 5 minus 2, I'd get 3. 3 to the third power would be 27. Multiplied by another 3 would be 81, plus 4 more to get us to 85. So that checks off. All right, so now we're going to solve, and we have to be sure to check for extraneous solutions. Similar to when we had extraneous solutions in Unit 6, where some of the answers would work, we do want to think about our domain restrictions, especially on this one. Because it's a negative fourth root of x, well, ignore the negative part, but the fourth root of x, since that's an even root, we need our x values to be greater than, excuse me, greater than or equal to 0 in this case. So whatever our answer is, we need to make sure that it's greater than or equal to 0 because if we plug it back in, we need to make sure it's positive. So for this one, to isolate the radical or the root here, we need to add it to the other side. So I'm going to add the fourth root of x to both sides. I know that feels kind of weird, but now we would have 5 on one side. We'd have a positive fourth root of x on the other, and then to undo a fourth root, you take it to the fourth power. We're going to increase it. So then we get x equal to 5 to the fourth power would be 625. That's 5 times itself 4 times. Okay, here we have a mixed fraction as our exponent. So we have 3x to the 4/3 power equal to 243. So let's get rid of the 3 first. Let's move that to the other side by dividing by 3. This one, I will admit, is a little bit harder to divide by 3 by hand. But x to the 4/3 is equal to 81. And if you're ever struggling with division by hand, remember that you can just start by breaking up the number. You can take 240, divide that by 3, and then you can take 3 divided by 3. 240, well, we know that 24 divided by 3 is 8, and since it has an extra 0, that would just be 80 plus 1. So if that helps when you're doing your division process. Now what I would do here is I would suggest rewriting this in a form you're more familiar with. X to the 4/3 power is the same as the cubed root of x to the 4th. Or if you don't like it there, if you've been practicing writing it on the outside, that would be easier for this problem here. The reason for that is because we can undo a 4th power by taking the 4th root of both sides. So now the fourth root and our fourth power are going to go away. And then the fourth root of 81, well, we just saw this, but 9 and 9 would break up into 3 and 3, 3 and 3, so it's a perfect group of 3's. And then to undo a cubed root, we would take it to the third power, make it bigger, and we'd get x equal to 27. Okay, here's our next one. Oh, I should also note, because it was a 4/3 power, since it was a cubed root, that was the radical, we didn't have to worry about a positive or negative value here, because cubed roots are only going to give us one answer out of that. Here we do have a limited domain. Because of this 2x plus 8, if we set that equal to 0 and solve, I'm going to subtract 8, I would get 2x equal to negative 8, divide by 2, I would get x equal to negative 4. So that means that if we get anything smaller than negative 4, that's not going to work for our answer here. So we want to make sure that whatever solution we get, it's greater than or equal to negative 4. All right, now I'm going to solve this one. So let's go back. Let me just erase this quick here. Let's isolate the square root. Because the 4 isn't underneath it, if I add it there, I would get 10, and then I'd get the square root of 2x plus 8. To undo a square root, we're going to square both sides. This one is pretty doable by hand. 10 squared is 100, and then the square and the square root are going to get rid of each other. And then we're going to subtract 8 here. 2x equals 92, divide by 2, and we get x equal to 46. Okay, on to the next one. This is probably going to be the hardest one of all to remember, but notice how we have two square roots. What we can do, and it's going to feel kind of weird, but because this is its own square root and this is its own square root, we're going to move them to opposite sides, because then we can square both sides and get rid of both of them at the same time. If you square them while they're on the same side, you're going to mess up the process of it, because you would actually have to FOIL it, and you don't want to go through that process. So instead, let's just move this entire thing over here to the right side. And now we have the square root of 4x plus 28 is equal to 3 times the square root of 2x. Now each of these have their own values for what we have to be considerate of in terms of like getting a positive answer under the square root. We could solve for both sides. The 4x plus 28 version is not as restricted or as the 2x part. So if I look at the 4x plus 28, if I were to set that equal to 0, I would subtract 28 from both sides. 4x is equal to negative 28, divide by 4. X is equal to negative 7. So our answer for that part only has to be greater than or equal to negative 7. But if I were to plug in negative 7 here, I would get an imaginary solution, because I'd have negative 14 under the square root. So because this one is more restrictive right here, that's the one I should also solve for. 2x equal to 0, divide by 2, x equals 0. So I need my answers to be greater than or equal to 0 would be the better version of that. So if I get anything less than 0, I know that's not going to work for a solution. So now, like I said, since we moved them to the other side, we can square both sides, and then I have to square this also. It becomes 4x plus 28 equals, because I'm squaring the 3, that becomes 9. This will just cross each other out, and I'm left with 2x here. So now, by simplifying, I'm going to get 18x. I'm going to subtract 4x. It looks like this one's going to work out really nicely. I get 28 equal to 14x, divide by 14, and x is equal to 2. So that is a good solution. It works for both. It meets the domain criteria in both of them, because it's greater than 0 and negative 7. Okay, now let's try this one. It was a couple lessons ago, but we saw a problem like this. When you're squaring to get rid of this square root, and you also have an x on this side, we do have to be considerate, like here, for our domain, because it's 2x plus 28, we just saw this one, oh no, never mind, it was a little different. But we do 2x plus 28 equal to 0. I just want to be considerate of the domain here. 2x equal to negative 28, divide by 2, divide by 2. X would be, can equal negative 14, so x has to be greater than or equal to negative 14. But because there's variables on both sides, here's the problem. If I got a negative 14 for my answer, and I plug that in for this x here, negative 14 plus 2 would be negative 12. I don't want a square root answer that ends up equaling negative 12, depending on what answer I get. So we do actually want our answer to be greater than or equal to negative 2, because that's what would make the left side equal to 0. So we actually need our domain to be greater than or equal to negative 2. Whatever we get, we need it to be at least that big. Okay. So now let's go ahead and try this. I also have to square this side. Remember, you're squaring both parts, so it's like you're putting it in parentheses. So this would be x plus 2 times x plus 2. The other side's going to be really nice. It's just going to be 2x plus 28, because these are inverse operations of each other. Now I'm going to FOIL. I'm going to get x squared plus 2x plus 2x plus 4. And because this is a quadratic, and we're masters of quadratics, we are going to move these terms to the left side. Actually, well, I can subtract a 2x here and subtract 28. I should have combined my terms first, but it's fine. X squared plus 2x minus 24 equal to 0. We want to set it equal to 0. Now I'm going to factor. Factors of 24 that have a difference of 2 are 6 and 4, positive 6, negative 4, which means my solutions are either x equal to negative 6 or x equals to 4. And I'm glad we discussed this earlier, but because we need our values to be greater than or equal to negative 2, negative 6 would not qualify as a viable solution, but 4 would. Okay, so then x equal to 4 is the only answer we can accept here. If I plugged in negative 6, it would work on the right side. I'd still get a positive answer. But by taking the square root of that number, I can't assume that I'm going to get a negative over here, because negative 6 plus 2 would be negative 4. So that's why it's kind of like a contradiction. Okay, last one. Here we would subtract 10, and I'd have 6x minus 5 equal to negative 7. And we can actually stop at this point. Hopefully we recognize, but we have a square root equal to a negative 7. We could definitely get an answer here. We could square both sides. But because it's already a square root equal to a negative number, we don't want to assume that any of the solutions we get are going to work, regardless if they seem like a nice answer, because we don't want a square root equal to a negative to start out our equation. So this one is just going to be no solution. All right, and that's it for this one.